Today is going to be 71-2, and we're going to be graphing a rational function with oblique asymptotes. Today's objective, we're going to graph a rational function with oblique or slant asymptotes. All right, so our first example asks us to sketch a detailed graph of this function. You're going to realize that the steps for this function is going to be very, very similar, except because our case is a little different, our asymptote is going to be a little different. But like I said, most of the steps are going to be the same. So the first one, it asks us to find the domain to determine our vertical asymptotes and our holes. So to do that, we're going to have to factor both the numerator and the denominator here. So we're going to want to factor this function right here. Well, to factor the numerator, we're going to have to do our p's over q's. Now to save time, if I did my p's over q's, my function is going to factor into 2x plus 1 times x plus 1 times x plus 1. The denominator, when that factors, that's going to factor into x plus 2 times x plus 1. So now I want to see if anything reduces. And so the x plus 1s do cancel out. And so my reduced function is going to be that 2x plus 1 times x plus 1 over x plus 2. So now I can determine what my vertical asymptotes and my holes were. Well, because x plus 1 canceled out, I do have a hole at x equals -1. And the denominator here, because it's x plus 2, if I set that equal to 0, I'm going to have a vertical asymptote again at x equals -2. Now I can find a few other pieces of information like the x and y intercepts. So my x-intercept, to be able to find that, remember you set equal to 0. So if I set the numerator equal to 0, I have 2x plus 1 and x plus 1. If I set that equal to 0, x is going to give me -1/2 and -1. And for my y-intercept, this is where you plug in 0 for x. And so plugging in 0 for x, if we notice everything over here, that's going to be 0, 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 and so I just get 1 over 2. And so my y-intercept is going to be 1/2. All right, so let's plot some of this information on our graph. So x equals -2. That's our vertical asymptote, and then we said that we have zeros at x equals -1/2 and -1, so like right there and right there. And then we have a y-intercept at x equals, or y equals +1/2, so right there. So now the last new piece here is going to be finding that horizontal or slant asymptote. Now we kind of discussed this already, but to be able to find that horizontal or slant asymptote, you have to divide the polynomials. And so that's what I want to do here. Now it's easiest if you use your reduced polynomial already. So if I were to multiply the top through, that's going to give me 2x squared plus 3x plus 1. And so I'll just use synthetic division because I'm able to. And so if I use synthetic division to divide this, bring down the 2, multiply, add, multiply, add. Now our remainder, the nice thing about this, you ignore it. We don't have to worry about it. And so I have a constant in my x, so my oblique asymptote is going to be the equation y equals 2x minus 1. Now I have to plot this. So to plot the 2x minus 1, the easiest thing to do is just create a table for it. So I can plug in 0, 1, and 2 in for x. Now if I do that, I get -1, +1, and 3. And so plotting that on my graph, I have -1. At 0, it's -1. At 1, it's 1. At 2, it's 3. And then following all that pattern all the way through, okay, I have my asymptote there. So now I have both my my vertical asymptote and my oblique asymptote graphed. Now to get the rest of my graph, I'm going to have to plug in an extra few points. So if we notice this area, I have a few points right here. Well, I don't really know the rest of the direction of where my graph is going. So maybe plugging in an extra point or two may help us out. So maybe I should try to plug in one. Maybe it'll be somewhere over here. So I can create another chart. And I can plug in 1 in for x. Now if I do that, if I plug in 1, 2 times 1 is 2, 2 plus 1 is 3, times 2 divided by 3. So 6 divided by 3, that's going to give me 2. And so I can go ahead and plot the value here at 2. So now from what I know about asymptotes, is that the graph always wants to go along them. So it looks like the direction here is it's going to come along here, and then it's going to kind of maybe like perhaps swing around, because it's not going to cross this. So it's probably going to swing around somehow, and it's going to want to come back through here. So I can draw my graph, swings back around, and that's going to be kind of a sketch of what's going on there. But now I need to find out what happens on this side. And so I need to pick a few extra values to be able to graph and plot what's happening on this side. So plugging in like -3 and -4. So if I plug in at -3, plugging that into my function here, that gives me -6 plus 1, which is -5, times -2, which is 10, divided by a -1, so I'm going to get -10. If I plug in -4, that'll give me -10.5. But those are going to be a few values that I can go ahead and plug in. So at -3, that's going to give me the -10, and the next one is going to be -10.5. Now I know it's off the graph, but it's still going to kind of follow that same pattern. And so that's going to be a sketch of our graph. So what I did here, everything has been the same except how I find my horizontal or slant asymptote. So I still found the domain and my vertical asymptotes for my hole, or for my vertical asymptotes and holes. So that's why I factored everything. The x plus 1's canceled out, which is why it was my hole or point of discontinuity. I set the denominator equal to 0. That's how I determined my vertical asymptote. I reduced my function to its lowest terms. That's what I have here. Then I found my x and y intercepts. The x-intercept, I set it equal to 0 and solved. We only have to worry about the numerator when we do that. So I set my numerator equal to 0 and solved, and that's how I got x equals -1/2 and x equals -1. Those are points that I was able to plot on the graph. My y-intercept, you plug in 0 for x, and so if I plugged in 0 for x, it reduced into 1/2, and so that's how I have a value there at 1/2. And then my horizontal and slant asymptote, to be able to find that, you have to divide the polynomials, which is what I did here. Now by dividing the polynomials, I got the equation 2x minus 1. That represents your oblique asymptote, this 2x minus 1 after I divided. Plot a few values to be able to sketch what that line looks like. Then, step 5, plot extra points and graph it. I didn't use a sign chart again. You don't necessarily have to, but I plot a few points to be able to get the sketch of what my graph is going to look like. Now, one little thing, we did say we had a hole at x equals -1. If you want to, on your graph, to represent that hole, wherever x is -1 on your graph, you can represent that with an open circle. So notice here, I can write an open circle at that value of -1. And so that would represent my hole. All right, example number 2. First step asks us to find the domain to determine vertical asymptotes and holes. Now, a few things to notice about this graph. You cannot factor the numerator, so it doesn't factor. Same with the denominator. It's not factorable. So because it can't factor out and there's nothing that we can reduce it, well, maybe I have a vertical asymptote. So for me to try that out, I have to set the denominator equal to 0. Well, if I do that, now I'm going to get imaginary values. If I take the square root of both sides, I'm going to get i's. Because if I take the square root of a -1. So there's no vertical asymptote. Nothing cancels out, so there weren't any holes. There is no reduced function. That is already the reduced function, so I can't even reduce it anymore. So let's try and find x and y intercepts. Well, my x-intercept, well, I have to now set the top equal to 0 and solve. Well, once again, if I take the fourth root, well, because I'm taking an even root of a value, that's also going to give me an imaginary value. Because what value to an even power is going to give me a negative number? It's impossible. So there's none. So there's no x-intercepts. Now for my y-intercepts. Well, if I plug in 0 for x, you get 1 over 1, which is just 1. Yay, I have something. Okay, so I have my y-intercept. So now for me to be able to find what my oblique asymptote is, you need to divide the polynomials. So x squared plus 1 is going to go into x to the 4th plus 1. Now if I were to divide these, x squared goes into x to the 4th, x squared times. Now when I multiply this back through, you should be looking, x squared times x squared, well, that gives me an x to the 4th. So that's good. But x squared times 1, that gives me an x squared. Where am I going to put it? Oh, that's right. I forgot to put placeholders. So I need to go through and make sure I need to put placeholders. I don't have an x cubed. I don't have an x squared. I don't have an x. And then I can put my plus 1. So now going through that, I could say plus x squared. So now I subtract. So that gives me a 0 and a minus x squared. And I can bring down that extra positive 1. I still have my 0x here, and I have my 0x cubed here. But now when I go through and divide this, x squared is going to go into this minus x squared only -1 times. Now because I said we don't have to worry about the remainder, we're done. This right here is our oblique asymptote, because anything else that I do, that's going to give me a remainder. And so now y equals x squared minus 1. Now I can go through and I can try and plot that. Now this is a parabola, and if you remember your parent graphs, this will help us out. It starts at -1, and then from there we can construct our parabola. And so this is our asymptote. It's a parabolic shaped asymptote. So now that I have my asymptote there, now I can plot points to be able to graph the rest of this. So plotting points, I can create my XY table. So I can plug in values. It seems like I have this 0 here, but maybe if I find what's happening here at 1 and at -1, so maybe those are values that I can plug in. Well, if I plug in -1 and +1 into here, -1 to the 4th is 1, -1 squared is 1. So I just get 2 over 2, which is 1. Now the same thing will happen with the +1. Well, this is kind of weird because I have my point there and I have a point there. It kind of makes us feel like, does that mean that they kind of cross through like that? And the answer is no. Like, you can't just assume that. Maybe it does. I don't know. But we may have to plot a few extra points and expect it a little further. So maybe I should plug in values like -0.5 and +0.5. Now when you do that, you get like 1.06 or something like that, 25. It's a really small number like that, which means that my graph, it's going to have like a small bump. And so there's going to be like these minor bumps that are going to appear there. And then if I plug in values like, let's say 2 and -2, well, that's going to give me 17 over 5, which is going to be like 3.4. So at 2, it's going to be like 3.4, which is about there. And so it's going to curve in and follow the asymptote along there. Now we can always take a look at this and enter this into a calculator to kind of verify further what else it's going to look like. So go ahead and get this one down. Right, so going over this problem here, x squared minus x minus 6 all over x plus 1. So find the domain to determine the vertical asymptotes and holes. So I should factor everything. And so this factors into x minus 3 and x plus 2. Well, nothing cancels out, so I only have a vertical asymptote at x equals -1. My function does not reduce either, so I don't have to worry about that. X and y intercepts, so my x-intercept, which means that I set the top equal to 0. So if I set that equal to 0 and solve, I get 3 and -2. So I know at -2 and at +3, I'm going to get my x-intercepts. Now for my y-intercepts, if I plug in 0 for everything, I'm going to get -6 over 1. And so my y-intercept, I'm going to get -6. Now for my oblique asymptote. Divide the polynomials. Now because it is x plus 1, there's no square or anything like that, I can use synthetic division. Make it easier on ourselves. Bring down the 1, multiply, add, remainder, get out of here, constant and x. So that's my equation there. Now if I wanted to follow the slope-intercept shortcut, it starts at -2, and I just plot the slope. And I can go through, and so there's my asymptote. Well, it looks like I already have this because I did all my intercepts, so it looks like the graph is going to do this. So maybe I just need to plot one more point. Maybe if I plug in -4. So if I plug in -4 into my function, I'm going to get, let's see, that'll be -3 in the denominator, so -7 times -2, so that's going to give me 14 all over -3, so 14 over 3, so that's going to be -14 thirds, which is going to be approximately -4.66. So 1, 2, 3, 4.66, and so my graph is going to do something like that. Alright, so this does conclude our lesson. If you have any other questions, please leave them in the comments.